Just a little note here. We often talk about p-values, and we might want to think that those are measuring the effect size. But in actuality, generally, they're measuring the sample size. You don't want to get confused. I'll go through some quick examples to remind. We would like to believe that we can get clear results from our statistical tests. The comic XKCD, the favorite cartoon of geeks, had a cartoon exactly this, showing the famous graph about vaccine usefulness. Plots cases of COVID against time. There's the group that got the vaccine. There's the group that did not get the vaccine and said get a placebo. The two groups, whoosh, completely diverged. The tagline is there. We reject the null hypothesis based on the hot damn check out this chart test. It'd be nice if we had more results like that from the world, but unfortunately we do not. That's the power of statistics, to extract sense from the noise of the world. Now again, actually that's not a statistics-free explanation there. There's a good bit of work beforehand, like pre-registered data collection, where researchers said this is what we're going to be measuring even before the study, etc. But commonly we're going to get a p-value below a chosen critical value such as 5%. We might believe that a p-value like that signals a case where the two distributions are like I've shown here. These two distributions are completely different. They're really far apart. With a sample size of just 4, I can distinguish a difference in means. This size at a p-value of 5%. With 4 observations, I can see huge effect sizes. But more commonly, I don't have just 4 observations and a huge effect. Instead, I might have a p-value of 5% with perhaps 100 observations. In that case, I can distinguish much smaller differences. These are standard normal distributions. You can see plus or minus 2 standard errors on the little X tick marks there. With more observations, you can distinguish really small differences here. Here, if I have 10,000 observations, then, oh my goodness, is there a difference? Maybe you just squint really hard, put your nose up against your computer screen, you might be able to spot a difference, but it's really small. That's a reminder of the power of statistics, but it's also a reminder of the limitations of the power of statistics. A nice low p-value does not necessarily mean there's a big honking difference. It may mean there was a really pretty small difference. Lots of companies do A/B tests where they put almost the same web page in front of different consumers, trying to see if they make different choices. But with a popular website, it's easy to generate tons of observations. So a p-value of 5% to demonstrate people prefer one layout or another, that's some incredibly tiny differences, which might not be important in the real world. There's a separate question. Are the differences important? A p-value does not tell you that these are important differences. Rather, it tells you we can distinguish. In the world, p-values are used and abused. If you want to play with this pictures yourself, this is the R code. You can play with that in the privacy of your own home.